Hi, everyone. What we're going to look at now is a little bit of details of how arrays are stored in memory. And so this is a little bit more detailed now. We've seen the basic syntax of how arrays are declared. So remember, we have the declaration is something like a type name, then the array name, and then the size. So, for example, we could have double measurements and 15. That would create an array of 15 measurements. And we also have the access, which is just the name and the index. So, for example, measurements at index 3 equals 2.7. That's what we just learned about. And now what we want to learn is how does this basics of array, how does that actually get handled underneath in the computer's memory? We know that every normal variable has an address because we can take the pointer of it. And so the questions that we want to try to answer now are, what is the address of an array? What's even the type of that address? And what about each part of the array? And how does that differ from the address of the array itself? And what does that mean? And so before I just tell you, let's look at an example program and do a little bit of experimentation to try to learn about it. Here's a small program. This is a slightly different syntax than we saw before, but it allows us to declare and initialize an array at the same time. And you can do this as long as the size of the array is a constant, like 3. Okay, so this is going to just make this array with 10, 15, and 8, and then print it out. So if I compile and run this, it's just going to tell us what those values are. No surprises so far. But now we want to try to understand the memory structure. So what can we do? Well, remember that we can use the %p in printf to print out pointer values. And so what I'm going to print out now is the address of each element of the array. Not the value of it, but the address of it instead. And so let's take a look at that. So as usual, the addresses are some large hex number that we can't really learn that much from. But what we can see is that there's a relationship here. And if we run this multiple times, we're always going to see the same relationship, which is that they're differing from each other by 4. So each position of the array is 4 after the previous position. So we can learn even more if we try to print out the address of the array itself, which we can say right here, the address of the array itself is, and we'll just say address of the array. So this isn't the address of one of the elements of the array, but the whole thing. And you can see if you can predict or guess what that might be. Let's find out. And what do you notice? Well, again, it's some big number that doesn't entirely mean a lot, but you should notice that it's exactly the same as the first element of the array. Okay, so what we're learning is that each of the array element addresses seem to be in a pattern, and the reason why they're differing by 4 bytes each time, as you maybe have guessed, is because the type that we're storing in there is ints, and ints have size 4 bytes each. And so that's why they take up 4 bytes each. And so what we're seeing is that the way that the compiler treats arrays is that there's really just one address for the array itself, and each of the individual elements is just kind of an offset from that address. So the first array element is offset of 0. That's why we write array index 0. And then the next element it's an offset of 1, but that means 4 bytes later because it's an int. And the next one is offset of 2, and that means 8 bytes later, again, because it's an int. And to understand why it's 8 bytes, a small comment in case you haven't seen this before is that in hex, C means 12. So this is really 4 plus 8. Okay, so let's draw a diagram of this, and this kind of diagram is going to be helpful for us when we think about arrays quite a bit for this class. So if we have some declaration like int array 3, like what we just saw, what does that actually mean? And I'll assign some values, 6, 3, and 8. What does that actually look like in memory, and how are we going to diagram this? Well, we have a single variable that's called ARR, and when we draw arrays, instead of just drawing one box, we're going to draw a rectangular box with multiple parts of it, and then we put the 3 values in here, like 6, 3, and 8. And the reason why we draw it like this is because those are actually together in memory, next to each other. So we don't know where the compiler in memory is going to decide to put these exactly, but we do know that they'll always be next to each other. And the reason is that, in terms of the implementation, is that, like I said before, really only the array has an address. And when we ask for something like array index 1, it's really just using that address of the array and adding 4 bytes to it. Again, 4 bytes because it's an int. If we had an array of doubles, it would be adding 8 bytes for each index. If we had an array of chars, it would be adding 1 byte for each index. And so we won't use this information all the time, but it's really important when we're using arrays to understand how they're laid out in memory. And some of the pitfalls that we'll see with arrays a little bit later have to do with forgetting about how this actually works. So this is the main takeaways, again, are that arrays are always going to be stored what's called contiguously, so next door in memory. And it's really only the array itself that has an address, which is the same as the address as the first thing in the array. The other addresses are calculated from that one based on the index that we give. Okay, so I'll see you next time.